For 710,000 years, the Taftan volcano was written off as extinct. But just 1 minute ago, scientists watched its summit surge upward, releasing gases that stunned even experts. No monitoring exists, no alarms. Yet the ground beneath southeastern Iran is on the move, baffling everyone who thought this mountain story was over. If dormant giants like Taftan can wake up, what else are we missing? Across the world, volcanoes once thought to be silent are stirring back to life. In recent years, scientists have documented a handful of cases where mountains labeled as dormant or even extinct began showing signs of unrest. The Chile's Cerro Negro complex on the Ecuador-Colombia border, for example, rumbled after centuries of quiet, sending tremors through towns that had forgotten what volcanic danger felt like. In the Canary Islands, Cumbre Vieja erupted in 2021 after half a century of calm, catching residents and authorities off guard despite decades of monitoring. The Global Volcanism Program, which tracks activity at more than 1,400 volcanoes, still lists most eruptions as coming from the usual suspects, those that erupt every few years or decades. But every so often, a volcano with no record of recent activity suddenly makes headlines. These rare awakenings, scattered across continents, challenge the idea that a long period of quiet means safety. In Indonesia, Mount Sinabung lay dormant for 4 centuries before erupting in 2010. In Chile, the Chaitén volcano was considered extinct until an explosive eruption in 2008 forced the evacuation of an entire town. Each event left scientists re-examining what it means for a volcano to be truly extinct. Despite these dramatic stories, the data do not show a global surge in dormant volcanoes waking up. The increase in reports often traces back to new technology, satellites that scan every corner of the planet, seismic networks that pick up the faintest tremor, and social media that spreads news in seconds. Many volcanoes once overlooked are now under the digital microscope. What's different is not the frequency of these awakenings, but our ability to detect them in real time. Still, the consequences of missing even one restless giant can be devastating, as seen in New Zealand's White Island tragedy in 2019, when a sudden explosion killed 22 people during what was thought to be a routine period of unrest. These isolated reactivations have forced a reckoning in the scientific community. Experts warn that the boundaries between active, dormant, and extinct are not as clear-cut as textbooks once claimed. Volcanic systems can slumber for tens of thousands, even hundreds of thousands of years, only to reactivate with little warning. The lesson is clear. Absence of evidence is not evidence of absence. As detection methods improve, more surprises are likely to surface. The world's mountains are not as predictable as we might hope. This uncertainty has driven a new urgency in volcanology. Researchers now push for more comprehensive monitoring, especially in regions where population growth has placed more communities within reach of once-forgotten hazards. The stakes are high, not just for the scientists who study these systems, but for everyone living in their shadow. In this global context, the story of a single volcano's awakening is more than a local event. It's a reminder that the Earth's deep processes rarely follow human timelines, and that our understanding remains incomplete, no matter how much technology advances. Taftan rises abruptly from the arid plains of southeastern Iran, its snow-dusted summit standing nearly 3,900 meters above sea level. This isolated peak, the tallest volcano in the region, dominates the borderlands where Iran meets Pakistan. For centuries, it was a landmark for travelers and herders, its rugged slopes and twin craters etched into the memory of the Baloch people who live in its shadow. Yet, in the world of earth science, Taftan was little more than a geological relic, a mountain shaped by ancient forces, long believed to be extinct. The volcano's roots run deep into the Makran subduction arc, a tectonic boundary stretching hundreds of kilometers along the southern edge of Iran. Here, the Arabian Plate grinds slowly beneath central Iran, driving rock and sediment deep into the mantle. This process creates conditions ripe for volcanism, much like the volatile arcs found in the Pacific Northwest or Russia's Kamchatka Peninsula. Yet unlike those regions, the Makran Arc is a place where eruptions are rare, and intervals between them can stretch across hundreds of thousands of years. Taftan's structure tells the story of its violent past. It is a classic stratovolcano, layer upon layer of hardened lava, ash, and volcanic debris built up over countless eruptions. Its flanks are scarred by old lava flows and dotted with fumarole fields that, until recently, vented only faint wisps of steam. The summit craters, once the source of powerful explosions, have been silent for so long that even local folklore refers to the mountain as the sleeping giant. Geological surveys in the late 20th century found no evidence of recent eruptions, and radiometric dating placed the last confirmed activity at roughly 710,000 years ago. By all conventional measures, Taftan fit the textbook definition of an extinct volcano. Scientists classified it as such for good reason. Between 2015 and 2020, satellite and ground-based observations showed almost no movement, less than a millimeter of vertical change per year. There were no significant gas emissions, no seismic tremors, and no thermal anomalies to suggest lingering heat or magmatic activity beneath the summit. In a region where resources for monitoring are scarce, Taftan was not a priority. Its long dormancy meant that, for decades, it received little attention from researchers or authorities. Yet the mountain's setting hints at a hidden potential for renewal. The Makran subduction zone is known for its unpredictability. Deep earthquakes, landslides, and the occasional mud volcano serve as reminders that the Earth here is far from stable. While most volcanoes in this arc have been quiet for millennia, their very existence is proof that the forces driving them have not disappeared. For Taftan, the assumption of extinction was always a matter of probability, not certainty, a calculation based on the absence of evidence, rather than on any definitive sign that its volcanic system was truly dead. This institutional consensus, shared by local geologists, international databases, and hazard planners, held firm until the first signs of change appeared. With no early warning systems in place and no permanent monitoring network on the mountain, Taftan's quiet reputation lulled both scientists and nearby communities into a sense of security. That sense would soon be shattered by a series of unexpected signals, forcing a rapid reassessment of what it means for a volcano to be truly dormant. In late September 2023, the familiar routines of the Baluchi herders on Taftan's lower slopes were interrupted by a sharp, acrid scent drifting on the wind. For generations, these families had watched the volcano's flanks for changes in weather or pasture, but the sight that morning was different. A thick column of smoke rising from the summit, visible even from the outskirts of Kash, some 50 kilometers away. The plume hung in the air for hours, tinged yellow by sulfur, and left a bitter taste that lingered in the mouths of villagers and livestock alike. Stories spread quickly through the region. Elders recalled old warnings: when the mountain breathes fire, it is best to keep your distance. Some families packed up their tents and herded their goats down to the dry riverbeds, sleeping under open skies for 2 nights before returning. Others debated whether the disturbance was a sign of a coming storm or just another quirk of the mountain's moods. But the sulfur stench and the sight of smoke unsettled even the most skeptical, stirring memories of tales handed down about Taftan's temper. With no official warning system in place, information traveled by word of mouth and through patchy cell phone service. Local teachers and shopkeepers compared photos and videos, trying to judge whether the plume was larger than usual or simply more visible in the autumn light. Some posted images to social media, drawing the attention of regional journalists and, eventually, university researchers hundreds of kilometers away. By the end of the week, a small team of geologists arrived to collect spot measurements. Their portable sensors picked up sulfur dioxide emissions spiking to nearly 20 tons per day, levels far above the trickle usually recorded in quiet years. The herders noticed other changes too. Springs near the crater edge ran hotter and stronger than usual. A few head of cattle refused to graze in their favorite meadows, skirting patches of scorched earth where the fumes clung low to the ground. Children complained of headaches and burning eyes when the wind shifted. Some villagers wondered aloud whether the government would issue an alert, but no sirens sounded, and no officials visited the settlements. The mountain, it seemed, was left to speak for itself. By early October, uncertainty had settled over the region like a second haze. The plume persisted, sometimes thinning, sometimes thickening, always unpredictable. Without instruments or experts on hand, the people closest to Taftan were left to interpret its signs as best they could. Their unease was palpable, rooted in first-hand observation, rather than distant rumor. For the first time in living memory, the volcano's presence was not just a feature of the landscape, but an active part of daily life, demanding attention, caution, and above all, answers that no one nearby could yet provide. In the months following the first sulfurous plumes, a doctoral researcher named Mohammed Hossein Mohammed Nia began sifting through stacks of raw satellite data. Using Sentinel-1 radar images, he tracked the shape of Taftan's summit, frame by frame, searching for subtle changes invisible to the naked eye. What he found was anything but subtle. Between July 2023 and May 2024, the southeastern summit had risen by 9 centimeters, a sudden vertical surge in a mountain that for years had barely budged more than a millimeter per year. This was not a glitch or an artifact. Atmospheric corrections and independent checks using multiple satellite passes ruled out noise. The ground was moving, and the numbers were hard to ignore. The deformation was not a single sharp bulge, but a broad, smooth uplift that spread like a slow ripple across the summit. Analysts described the pattern as a traveling wave, a gradual, coordinated rise rather than a local blowout. Such a signal pointed to a process unfolding deep below the surface, not a landslide or surface collapse. Forward modeling placed the source of this movement at a depth of roughly 490 to 630 meters beneath the summit. The models, whether assuming a spherical point of pressure, a shallow sill, or an elongated crack, all converged on the same shallow zone. The amount of material required to lift the summit by 9 centimeters in less than a year was staggering, especially for a volcano that had been written off as inert. For comparison, from 2015 to 2020, Taftan's summit had shifted less than a millimeter each year. The baseline was flat, unremarkable, and consistent with a cold, dead system. To see such rapid inflation now, with no major earthquakes or external triggers in the region, was a clear signal of unrest. The pressure change implied by the uplift could not be explained by seasonal rain, snowmelt, or surface erosion. All evidence pointed to new energy working its way up from the depths. Every step of the analysis was checked and rechecked. Atmospheric noise was filtered out using advanced corrections. Topographic errors were minimized by comparing datasets from different orbits and masking out unreliable areas. The team ran Bayesian inversion and bootstrap routines to test the depth and volume of the source, quantifying uncertainties down to tens of meters. The results held up. The summit was rising, and the source was shallow. The scale and speed of the deformation forced the scientific community to take notice. Internal memos show that initial warnings were met with skepticism. Some officials dismissed the data as a technical anomaly, but after third-party validation by international remote sensing teams, the reality became impossible to deny. Taftan was no longer a silent relic. The ground itself was sending a message, and the numbers spoke louder than any rumor or eyewitness account. For the first time in living memory, the mountain's story was being written in centimeters, measured from space, confirmed by science, and impossible to ignore. No earthquake, landslide, or heavy rainfall explains the sudden rise of Taftan's summit. With external triggers ruled out, Scientists are left with two competing possibilities, each carrying its own risks. The first scenario points to hydrothermal pressurization. Hot water and gas, trapped beneath mineralized seals, can build up pressure over months or years. If the seal breaks, the result is often a violent steam-driven explosion, dangerous even if no fresh magma reaches the surface. The second scenario considers the movement of magma. Small batches of molten rock rising from deeper reservoirs can inject gases into the hydrothermal system. This process, while subtle, is known to drive uplift patterns like those seen at Taftan. Both models fit the data. A shallow source, just 490 to 630 meters beneath the summit, and a distinctive traveling wave of ground deformation. Senior volcanologists admit the evidence is ambiguous. Without direct gas sampling or seismic sensors on the mountain, even the most advanced satellite models can only narrow the range of possibilities. The limits of current knowledge are clear. Something is changing deep inside Taftan, but whether it is water, gas, or magma remains an open question. Inside Iran's crisis management offices, the first official responses to Taftan's awakening were tangled in paperwork and competing priorities. The Geological Survey flagged the need for urgent monitoring, permanent seismic and gas sensors, continuous satellite feeds, and TKT and a dedicated early warning system. But requests for funding ran into a wall of bureaucratic gridlock. Budget memos show that resources earmarked for volcano monitoring were quietly shifted to flood relief and border security. Defense officials, wary of the mountain's proximity to Pakistan, insisted on military oversight before any foreign-made equipment could be installed. Meanwhile, the Ministry of Interior cited a lack of formal clearance for deploying new sensors, worried that publicizing volcanic unrest might trigger panic or diplomatic friction. No permanent seismic network covers Taftan. There are no automated gas detectors, no ground-based GPS receivers, and no local hazard sirens. The only data reaching Tehran comes from spot measurements and foreign satellites. Proposals for joint monitoring with Pakistan's Suparco agency stalled over disagreements about data sharing and border demarcation. Regional authorities drafted emergency plans, but without real-time information, any warning would arrive too late. In this institutional vacuum, the risk remains invisible, unquantified, unaddressed, and dangerously underestimated. Recent history offers sobering lessons about what unrest at a volcano like Taftan can mean for those living nearby. In Italy, the ground beneath Campi Flegrei has lifted several meters over decades, prompting constant vigilance. But so far, no eruption. At La Fossa, another Italian caldera, authorities raised alarms and evacuated parts of the island after similar ground swelling and gas release, only for the crisis to pass without major incident. Yet the story is not always so forgiving. In Iceland, Svartsengi's restless phase began with subtle ground rise and ended with a sudden eruption that forced communities to scramble for safety. The most haunting example comes from New Zealand's White Island, where a steam-driven explosion in 2019 killed 22 people during an ordinary tourist visit. No fresh magma needed, just pressurized steam and gas breaking free. Even without molten rock reaching the surface, phreatic blasts and toxic gas clouds can turn a quiet landscape deadly in moments. For the Baluchi herders and villagers at Taftan's base, the challenge is clear. Danger does not always announce itself with fire and ash. Sometimes, it arrives as a silent, invisible threat, demanding respect and a readiness to act, even when the outcome remains uncertain. Between July 2023 and May 2024, satellite data confirmed that Taftan's summit rose by 9 centimeters after 710,000 years of near-total dormancy. Scientists have ruled out earthquakes, rainfall, or other external triggers, leaving only internal volcanic processes as the source of this sudden change. Gas emissions and ground deformation mirror patterns seen at other volcanoes that have erupted and those that have not. Yet, with no early warning system or continuous monitoring in place, both the cause and the future of this unrest remain uncertain. Official reports confirm that the source lies 490 to 630 meters below the surface, but whether this means rising magma or trapped gas is still unknown. As of June 2024, Taftan stands as one of the least monitored yet most closely watched volcanoes in the region. The evidence is clear. Dormant does not mean safe, and the risks of inaction are no longer theoretical.